Hello everyone. When I'm teaching technical drafting and computer-aided design, the first few sessions, especially when I'm doing computer-aided design, I go over drawing isometric views and orthographic views. And one of the problems that I give to my students is, like here, I give them three views, the standard views, front, top, and right, and I ask them to draw the isometric view of the object. Now, some people have very good 3D imaginations, and when you give them these views and say this guy here is the front, that is top, that is right, they can very well imagine how the object would look like in the space, and then of course they can draw the isometric view. But not everybody has this capability, right? And so my students asked, and some of you might ask, how would you infer the 3D shape of the object if I just give you the three views? Sometimes even one of these views could be what? Eliminated. I just give you two views and I ask you to give me the third view as well as the isometric. How would you do that? Well, when I was in undergrad, I had this method called surface analysis, and also volume analysis that is completely logical and analytical method without really expecting you to have very good 3D imagination to do this job. So in this video, I want to go over that. So here I have two practice problems, the one on the top that has no invisible lines and the one in the bottom that has some dashed lines. And we want to do surface analysis on it, and I'll show you how it is done, and then we draw the isometric on the right side. Before I do that, I want to just refresh your mind from the orthographic views. You have seen these in my previous videos, but I want you to refresh your minds how we get these three standard orthographic views. So if we put the object in a glass box and project the object, any point on it, onto all six walls of this cube using perpendicular projecting rays, that's why we call it orthographic, and then unfold the box, then we get six views, as you can see here on the right side. And out of the six views, you have three pairs, and these pairs, they have redundant information. So like the right looks like the left, except for some visibles become invisibles or vice versa. Top is like the bottom, front is like the rear. So we eliminate the rear left and the bottom. We only keep what? We only keep this top, front, and right. And that's what you see here, right? That's those three views that you have. The other piece of information that is very crucial is the front and top view should be exactly below each other, as you can see here, right? So if I have, for example, this surface, this is a small rectangular surface, and I call it A, then if I basically transfer this surface to the top view using these two vertical lines, then the only feature that matches this A in this top view is this basically inclined edge, right? Or if I go between what? Between the front and the right view, then they are perfectly horizontally aligned. So if I want to say what is this circle, this bigger circle or the smaller circle, if I use these horizontal rays, then I can see clearly that the big circle is this guy and this is what? The smaller circle, right? Because only those will match the dimensions. And if I want to go between top and right, then I have to use a combination of vertical lines, as you can see, horizontal lines, and then 45-degree angle lines, which are drawn between the folding lines of the box. So these guys here, these are the folding lines of that glass box that you can see here, these lines. And the question is, where is your object inside the box? Is it exactly in the middle? Is it a little bit closer to the front or back or whatever? Well, the matter of fact, it's not going to change the shape of any of these views. Wherever it is inside the box, these six views will be the same. So what's the only difference? The only difference are these gaps. So for example, if it's closer to what? If you bring this guy close to the front plane, then what you have in the top view, this gap here will be what? Will be smaller. On the other hand, this gap will be bigger, right? So that's all there is. And the location of the object within the box is not going to change anything meaningful. So if you ask me, if I have these three views, where would I draw these folding lines, like in this practice problem? Where would I draw the folding lines? Well, it does not really matter that much, but the easiest way to do it, if you want to transfer dimensions between top and right view, is if you look here, the gap that you have between front and top is 1 unit. The gap between front and right is also 1 unit. So if I want to draw a line between what? Between folding lines, I draw it exactly in the middle, right? So here I go and I draw it exactly half of that 1 unit. If I can do that, let's see if I can roughly get something like that, right? So I do something like this, and then here I do the other one. So I put my folding lines somewhere like that. Okay, and those would help me what? Would help me transfer the dimensions between right and the top view, as you can see here. So let me tell you an example about that here. So if here I say this surface is A and this guy is B, what do they represent, or what are they represented by in this top view? So if I use this vertical 45-degree and horizontal lines, then I see that A represents this guy and B represents that guy, that vertical edge, right? So transferring dimensions is very, very useful for knowing which surface corresponds to which other surface or which other edge in the other views. Once we know what kind of surface we are dealing with, then drawing it in the isometric view is not hard. And the other piece of information that you need to know, and I mentioned again in one of my previous videos, is the three types of surfaces in general that you can have. So we have normal surfaces or parallel surfaces. This kind of surface, like this guy, it is parallel to one of the three major views, and by major views again I mean front, top, and right. So here, this guy here is parallel to the front view, and then it is what? It is a perpendicular. Let's see if my, there we go. It's parallel to this view, and it's perpendicular to the two other views. So in that view that it is parallel to, you see it full size, and in the two other views that it is perpendicular to, you see it as a horizontal or vertical edge. It is also called a surface type 1. Then we have surface type 2, or inclined surface. This guy is not parallel to anything. Okay, this guy is not parallel to anything. It's just perpendicular to one of the views, in which it appears as an inclined edge, and in the two other views that is not parallel nor perpendicular, it looks like a surface, but both of them are smaller than what? Than the actual surface. And finally, we have surface what? Type 3, that we also call the oblique surface. And this guy here is not parallel, not perpendicular to any view. In all views, it appears as a surface, all of which are smaller than the actual surface. Now, knowing all of that information, let's go ahead and do the surface analysis method. So what we do here is, any surface that we see in these views, we give it a name, okay? So in the front view, we start, if we call this A, and then I call this guy B. Now my first question is any of these other, in any of these other views, the top and right, do I see A and B? And if I see them, is that another surface or is that an edge? Now, one of the important things, other than those alignments that you have vertical alignment, horizontal alignment, and then there's vertical, horizontal, 45-degree or 90-degree rotation alignment. Other than that, another important principle is this, that, for example, if you look at A, how many corners does A have? Well, clearly you say 1, 2, 3, 4, 5, 6 corners A has. Now, if A is one of these two guys, right, one of these two surfaces, so is A this one or this one? Now, what would you say? Well, I say none of them. Why is that? Well, it cannot be the A on the left. Why? Because A on the left has only 4 corners, but here on the front view it has 6 corners. And there is no way that you can see a surface in one view with 6 corners, in the other one is what? 4 corners. So one of the important principles that you want to keep in mind, let me go here and type it, is that number of corners for surfaces do not change from one view to another view. Okay, that is an extremely important principle that you have to keep in mind, that it's not going to change. Okay, this is the important principle. So it cannot be the one on the left. It's impossible. Now, what about the right? Can it be the one on the right? And the answer is again no. You might say, well, why not? That guy looks like 6 corners. This is 6 corners. Yes, but if you transfer the boundaries of A, the left and the right side of it, vertically, you see clearly it does not match A. A has some portion that is not vertically above this A in the bottom, right? So this A on the top is not exactly above the A in the front view. So that for that reason, that cannot also be what? A, right? So none of those surfaces can be A. Now, what about B? Can any of these two be B? Again, the answer is no. Why? Because, first of all, this guy here, this rectangle is not above that B. Okay, clearly it's not vertically above it. And this other kind of L-shaped surface, it has way more corners than this simple square B. So none of them can be A and B. Therefore, if you would be okay, I would call them C and D. These surfaces, I would call them C and D. Now the question is, fine, those are C and D. They are not A and B. Now where is A, where is B in the top view? And the answer is, well, A can only be what? A is a surface in one view, right? So in the other view, it can either be a surface or edge. None of the surfaces would match, so it can only be an edge. And which edge? That edge should be right above what? Should be right above A. So the only edge that here matches is this here, this small edge on the front. So here I would call this edge here, right? This edge on the front, I would call it A, and it cannot be on the back. You might say, what? Can it be this portion on the back? No. Why? Because if it's in the back, then I'm not going to see it. It has visible edges, so it has to be on the front. Okay, so that is A, fine. Where is B? Again, I transfer B vertically using this edge, this ray, and this ray, and the only option you have is this edge here. So that guy is what? B. So A and B, in two views, they are horizontal edges. In two views, they are surfaces. And if I go and look at my options, what is my option? I have a horizontal edge in one view and a surface. You see, the only option you can have is this guy. In one view, it's a horizontal edge. In one view, it's a surface. In the other view, then probably they should look like a vertical edge or something. Okay, so if I want to find A and B here in the right view, as we'll do, they are most probably a vertical edge, and we'll go over them in a second. But for now, let's figure out C and D in the front view, and then we'll continue. So what about C and D now? So now that I found A and B, fine. How do I find what? C and D in the front view? Well, again, I use my projector rays. I bring C down here, and the only edge, because there is no surface for C, the only edge that matches C is this top surface here. And if I bring D down using the left and the right side of it, the only thing that matches is this edge here. This edge from here, this corner to that corner. So there we go. I got C and D, right? So I got A and B, C and D, they're all figured out. Now let's go to what? Let's go to the right view. A, B, C, D are already figured. Now the question is, can any of these guys be A, B, C, or D? Well, let's find out. None of them clearly can be A or D. Why? Because all of these guys, all of these three surfaces in the right, they have 3 corners. A and D have 6 corners. So A and D are out of question. What about B or C? Can B or C be what? Be anything here? And the answer is what? Well, let's first look at C. If I want to transfer C, C here is a simple edge, right? All of the C should only be on this area and nothing else, right? Because all of C is on that edge, so all of C should be on some edge here. So there is no way C can be any of these surfaces. So C is also out of question. So the only thing left is D. Now, if I bring D, vertically project D, if I bring D from, B, if I'm bringing B from the top view to the right view, how do I do it? Remember, I use a vertical, horizontal edge, then I use what? I use a 45-degree angle, then I bring in a what? A vertical. So if I do that, this is my 45-degree angle, and then I bring in a vertical. So B should be on this vertical edge, because all of the B is on this guy, so all of the B should be on this vertical edge, not on any of the surfaces. So the answer is none of these surfaces can be what? B, but B is definitely what? B is definitely on this vertical edge, and C is on that horizontal edge. Well, so I got my answers. Clearly C is this horizontal edge here, right? B is somewhere on this vertical edge. Now, what is it? What on this vertical edge can be a potential for B? Well, the only vertical edge you have is this small portion. So this guy here can be what? This vertical edge is B, that small one, and that top horizontal edge is what? C, but none of the surfaces are clearly A, B, C, or D. So now I give these surfaces some new names. So I call them what? I call them E, this top rectangle. Then these small squares on the bottom, I call them F and G, if you don't mind. And now my question is, where is F, where is G, where is E, and where is A and D on my right view? Okay, so let's go ahead and figure them out. So where is A? And where is what? Where is D? So A, if you look at it, if you transfer A using this top ray and the bottom ray, A has to be a surface, or we know it cannot be a surface because in this view it's a surface, in that view it's an edge. So clearly in this other view it's a vertical edge. It's a vertical edge that is spanning the entire height between here to here. So the question is, where is it? And the only 2 options that I have are what? Are this edge here is either this edge or this edge. There is no other way. And which one is it? Well, the question is, here is front view, this is the right view, right? So which one could be? If it's this guy here, where is that edge? It's on the very right side of the object, right? Sorry, on the right side of the right view. Remember, when I have a box in the isometric view, this is my isometric view. This is the front view. This is the right view. This is the top view. If I have some edge in the right view on the right side, it is here. If it's this guy, it should be on the right of the right view, so it's here. Now, if I look at it in the front, can I see something that is really in the back? Can I, in the front view, can I see something in the rear? No. But if it's this edge here, if it's this edge, which is this guy here, right, it is going to be seen in the front view. So between these two, which option is possible? Only this guy. So what is my option here? My option is this guy. This vertical edge here is A, right? What about D? Well, if I use projector rays and I transfer D using the same method I did for B, so here I have that ray and this ray. If I use the 45-degree angle and come down, then you will clearly see it is going to get the entire depth of the object. Now, which edges have the entire depth of the object? There is the top edge, which clearly belongs to C. So that is out of the question. So the only two edges that I have is this guy and this one. Now this one is at the very bottom and I cannot see it in the top view. So the only option is somewhere here in the middle that I can see. So only this guy can be what? Can be D. There is no other way around it. And so here, if we go ahead and use that, right, then the only option you have for D is this edge here. So here we go. I got A, C, B, D in all views. Now I need E, F, and G. And for E, F, and G, all you need is to use these horizontal alignment with the front view. If you use E, clearly you see the only option is going to be that edge over there, right? So this guy is going to be your E. And if you use F and G and project them, then F and G should be what? They should be a surface here. There is no surface to match them, or they should be an edge here that has that much of height from here to here. And there are two edges to match that. One is this edge here on the front, one is this edge a little bit back. Now the question is, which one of them is F, which one of them is G? Right? One of them is F, one of them is G. How can I tell? So this is where first, before I do my final decision, I transfer F and G to the top view. Look, if I transfer F to the top view, clearly you would see if I transfer F to the top view, then this guy has to be F, and if I transfer G to the top view, then this guy has to be G, right? So now I can answer my question. Which one is F, which one is G? Well, F should be below F. So if this is F, below F should be F. So this is F. And below G should be G. So this front edge is what? G. You see? Without me doing any imagination, none, zero imagination, purely by logic, by alignments of the views, I could infer that this guy is F and this guy is what? G, and now I have everything. Now I know I have 7 surfaces, A to G, and I know that they are all surface type 1, because in one view they are a surface, in the other views they are an edge. And I can start what? Drawing the isometric view. Now let me show you how you draw the isometric view. And now you might say, could I just get my right view even if I don't have the right view? If somebody only gives me the front and the top, can I have the right view without having the isometric? The answer is yes. I'll show you that as well. But let's first draw the isometric, and then I'll show you the right view. If I don't have this, if I eliminate this, can I draw the right view? And I'll show you the answer is absolutely yes. So first, let's draw the isometric. How do I draw the isometric? Well, I draw the bounding box, as you have seen in my other videos. The dimensions is what? You have 4 units in depth, you have 4 units in height, and you have what? 6 units in width. So I start anywhere that I want. I go 4 units in depth, I go 4 units in height, and then I go 6 units in depth, and then I draw my bounding box. Here. That's my bounding box. Now the question is, where do my surfaces go? Well, you can start with any of them. So where is C? Well, if you look at C, it's a 2x4 surface, and it's on the very top. What? It's on the very top of the object. So C is clearly here. This is C. What about, let's say A? Well, if you look at A, it's this L-shaped surface, and it's on the front of the object. So I can easily go ahead and draw this L-shaped surface for A. A is this guy. What about G? If you look at G, G is on the very right of the object, 1 by 1. So G is like this. You see, I have done no imagination so far. Now what? Now let's look at E. E is limited to C and E. One edge of E is sharing with C. The other edge of it is sharing with what? With A, if you look at this view. And it's a rectangle 2x4. So if I use that edge of C and this edge of A, and I draw a what? A 2x4 rectangle, this is clearly E. Now what else? Well, let's look at some other surfaces. Like what? Like, for example, the D surface. What does D have? Well, D shares this edge with G, right? And here you clearly see that it has a connection to E, right? So D has one edge of E sharing with it. It has one edge of G sharing with it, so it's this edge, it is this edge, and then also you have a small edge sharing with A. So D has a small edge sharing with A, because this is D and this is A, so there is a small edge sharing with A, which is this guy, and it's an L-shaped surface. So all I need to do is to draw the L shape, which is this guy here. If I draw this L shape, this is your D, and clearly the other two surfaces that you have are F and B, which clearly, if you draw these 3 lines that I'm drawing right now, then this is what F and this is what B, and done. And all you need to do is to get rid of the blue edges that are not used in the bounding box, and you're done. Here. Right? That's my isometric. So you see, no imagination needed. All you need is pure logic. This method is called surface analysis. Now let me go back to the question that I asked you a minute ago is, can I get my right view without having it? So the answer is yes. Let me show you how. So here, I have eliminated the right view, right, in this top practice. I have eliminated the right view, and the question is, can I get the right view? Yes. Well, I don't want to redo the analysis, you know it. So that's how we determined A, B, C, and D in the example. Now, the question is that enough to draw the right view? Not entirely. Why? Because I did not determine every entity that I see in the top and front. And you might say, what is it that you haven't determined? The answer is the edges. If you look, all of the surfaces are determined, not the edges. There are some edges in these views that I don't know anything about. And you might say, where are they? Well, here. This is one edge, this is one edge, this is one edge. I don't know anything about these three edges, and I don't know this edge, and I don't know this edge, right? So I don't know anything about them. So the question is, let's give them some names, right? And see if we can do anything about it, correct? Or before that, do you want to determine where is A, B, C, and D in the right view, then we go about it? Well, yes, we can. So first of all, if there is a right view, where would it be? Well, you know the right view is going to have 4 units of height and 4 units of width. And there will be 1 unit gap between that and the front view. So if you leave 1 unit gap, the right view should be limited to this 4 by 4 square, basically. The right view should be inside that 4 by 4, right? That's where the right view belongs. Now let's go ahead and draw the right view if we can. At least start with A, B, C, and D. But what is A? Where is A? Well, let's look at A first. There's a color here. Where is A? Well, if I project A onto the right view, clearly it has to be what? We know in one view it's an edge, in one view it's a surface, so in the other view it has to be a vertical edge. And we know, we discussed between the left edge and the right edge, A has to be the left edge, so I can see it in the front view. So this guy here, from here to here, that is A. Right? That's A. If I project B onto the right view, again, in one view it's a horizontal edge, in one view it's a surface, in the other view it's a vertical edge, B cannot be on A. Why cannot be on A? Because here there is a break between them. And it cannot be on the very right side. It's impossible to be on the right side. So it's somewhere in the middle, but where is it in the middle? It's a vertical edge with a 2 units height. But where is it? Here, that's where I use my what? I use my projection from the top view to the right view. And let me use those folding lines again one more time. Put them down here so we can see stuff better. So this is one and this is one. Let's see if I can bring it down a little bit. So it's exactly somewhere in the middle. Okay, there we go. So if I bring B down, where would it end up? Well, if I bring B down using a horizontal, using a 45-degree, and going down, clearly you see B has to be on this vertical edge. B has to be on this vertical edge. At the same time, B has to be between these two horizontal edges. So this intersection here, from here to here, that is the only possible what? Solution for B. So here we go. I only keep the intersection to keep this a little bit clean. And B has to be this. So this is B. That edge was A. So I got A and B. Let me get rid of this bounding box for now. Do a little bit of cleaning so we can see stuff better. So I got A and B. Now where is C? Where is D? So C has to come to this horizontal edge. And C, again, if you project it, it has to get the entire depth. And if you intersect those two lines with this horizontal edge, then this edge here, from here to here, this guy has to be what? C, because C in one view is a surface, and the other one it's a horizontal edge. In this view can also be a horizontal edge. And keep in mind that the normal surfaces do not necessarily have to be a horizontal edge in one and a vertical edge in the other one and a surface in the third view. No, as you can see here, it's a surface in one view, and in the two other views it's just a horizontal edge. So keep in mind that as we had in here a horizontal and a vertical, that's not always the case. Sometimes you can have both horizontal edge, like as you can see here. So that's C. And finally, if I do something for D, you clearly can see for D, I have this area for D, and if I do a transfer for D again, I'm gonna get the entire what? And I'm gonna get the entire depth again. So D has to be on that edge. So here I clean it up, and I'm gonna go and draw D for you. So D is this guy from here to here. So now I got what? I got D, and the question is, what about the rest of the right view? Well, as you can clearly see here, there are two edges missing in the right view. One is the bottom edge, and I can see the entire bottom of the object. And one is the right edge, and I can see the entire right edge of the object. So I can draw the entire right edge, and I can draw the entire bottom edge. So this is already my right view, which you can see on the top. And that's it, I'm done. Do I need to determine these other surfaces that now came into existence, right? Like this guy E, like this guy F, and this guy G? Not really, but you know, we already determined that. But so you see, just with the two views, I can always get a third view if I use the projections. If I can transfer dimensions properly, I can easily what? I can easily determine the third view, even if I don't have the isometric. This is the power of the surface analysis method. And finally, let me do one more analysis for you before we finish this video. So hopefully you learn this method with some more extra practice, I would say. So here we have some hidden features. Can we still do the job? Let's see. So here I have surface A, I have surface B, and I have surface C. Do I see any of them in my top view? Well, let's see. Here, if I transfer B and C, there is no surface with visible edges that match B and C. Okay? And remember that the top of B and C is the top of the object. So the top of B and C reaches the top of the object. So B and C cannot be invisible. B and C cannot be cavities that are cut into object, because the top of them reaches the top of the object. So I cannot say this guy here is B and this guy here is C. Why? Because they had two invisible set of edges. It's impossible for the object to have such a thing. So that is not a possibility. And there is nothing else that matches them right above B and right above C that matches them. So the only options for B and C is, for B is this edge here, and for C is that edge over there. That's it. Nothing else can match B and C. What about A? Well, if I want to transfer A includes the entire width of the object. So it should be something that matches the entire width of the object. There are two options. Two. What are they? One is this invisible edge here. The other one is the entire surface, this C-shaped surface. Now, can a surface in one view looks like this, and the other view it looks like this? And what about the number of corners? If you look at the corners, well, you clearly see that this guy here, it has 4, 5, 6, 7, 8, and A also has 8. So in terms of corners, right, they match. But what about the shape? Do they match shape? Is there any way I can look some surface like this, a C-shaped surface, and in the other view it looks like something like this? Is that a possibility? No. Right? It's impossible. The formation of the shape is not possible. So the overall shape of the object will not also change. If it's a C, it would also look something similar to a C. Right? So that is not an option. A can only be what? Can only be this invisible edge. So if I want to here choose an option for A, the only option for A is this invisible edge. That's it. Now in the top view there is a surface that has no answer to it, and that is the C-shaped surface. If I call it D, the answer is, where is D down here? So if we transfer D down, the only options is the top edge and the bottom edge, but I see it in the top one, so it cannot be the bottom one, so it's only the top edge here. That's D. So there we go. I got A, B, C, and D. Now where are A, B, C, and D in the right view? Let's get them. So A is what? In one view is a horizontal edge, in one view is a surface, so in the other view it has to be a horizontal or vertical edge. If I use, let me use these folding lines, so this is 1 and this is 1. And if I use my folding lines clearly for A, it is going to come here. So A has to be on that guy, and it has to be between the top and the bottom one. So A, the only option for A is this edge here. That's A. What about D? Well, D is on the top edge and it has the entire width of the object. So clearly this top edge here is D because it horizontally matches the front view, and if you transfer the entire depth of that, you clearly see that it has to take the entire depth. So that top edge is what? D. Let me do a little bit cleanup so we can continue for the rest of it. So I got A, I got D, and now what about B and C? Well, B and C, they have to be moved with these lines, so there is no surface that is matching them, unless we say one of this surface with an invisible is B and C, right? Or one of the edges is B and C. But if we get help from the top view, where are B and C? So if we transfer B and C, clearly B and C they have to be on this vertical what? Edge, both of them. So the only option here for B and C is overlap. B and C are both in the same place. This edge here, this guy, is both B and C. That's the only option available for B and C. They are at the same level when you look from the right side. Now, am I done? No. There is this L-shaped surface in the right view that has no correspondence. So if I call this E now, where is E? Well, if I transfer E using horizontal edges, the only solution for E is this edge here and clearly that edge here. And I guess at this point I'm done because I have determined everything. Now, how do I draw the isometric? Well, if you look at the dimensions, it is 4 units depth, 4 units height, and 6 unit width. So we have to do something similar to the last time here. There's 3 and 6. This is 4. This is 4. That's my bounding box. Which surfaces are easy to draw? Well, let's see. So D is this C-shaped surface and it is on the top. As you can see, D is on the top C-shaped surface. And so D is going to be this guy. Here, that is D. Then what? B and C are in the front, as you can see them, and they are on this top left and top right corner one by one. So this guy here is going to be B, and this guy here is going to be C. E can be seen on the very right, and it is this L-shape, inverse L-shape surface. So this is E. And where is A? A is this kind of perpendicular sign shape, but it is 2 units behind the front. And if I try to find the corners of A and draw the edges of A, where is A is going to be? One of the edges is this guy. One of them is this one. One of them is kind of this invisible one. One of them is this invisible one. This visible, this visible. There is an invisible here that fits on the top of the, overlaps with the visible, so you only show the visible. And then there is this guy. So if I use my other color, A is like here. Okay, and if I want to show A is like this. A is that, with those black edges. All right, let me, that's A, 2 units back. Now, from the edges of A, which one should I draw? Because some of them are already covered by the edges of other surfaces. So whichever one that is missing, this guy here, this one is an invisible, as well as the one that I had here. You know, in an isometric view, you are not going to show invisible edges. So I'm not going to do this, and I'm not going to do this. This is the one that is missing. This is the one that is missing, right? And I assume that's it. So if I clean up the red edges, clean them up so I can see what I'm doing. There we go. Do I have everything? Yes. All of the edge, because this part of A is going to go here as an invisible again, and I cannot see that. It's going to be right behind this square going to be right below it, below that square surface. And again, I'm not going to do invisibles. So that's all I have. There are some, so this guy here is A is also here, A is also here. These are the portions of A that you can see from this view. There is some new surface that emerges here, like this guy. You might call it F. Where is F? F is here. Right, that is F. F is here. And in the top view, this is F. There is a surface here in front of F, which we don't see. It's like here. That surface that you don't see it. You might call it whatever you want. You might call that G. G is gonna be here. And in here, this is gonna be F and G. All right, so that's your isometric. These are your views all analyzed, and this is all I have. So hopefully this video is useful to you. The two principles, remember, that we have to keep in the surface analysis method is the number of corners of surfaces do not change, and the overall shape of a surface does not change from one view to another. So these are some important principles that hopefully you keep in mind, as well as the alignments, right? These are important alignments that we had. This one, and this one. And that is enough to draw the third view if it's missing, as well as once you have the third view, you can draw the isometric. And no imagination is needed. Thank you so much. I will see you in my next video.